Good morning, students. This is Mr. Keister here with you today. This is the video for Wednesday, August the 26th, which is our scheduled fifth day of school for the fall semester. One thing, always keep in mind that the dates can change on our calendar, on our schedule, for various reasons. Not to mention, of course, which the top one and probably is COVID-19. But regardless of that, even though the dates of the lessons or activities could change based on when I record these videos, the lessons will remain the same. So if a date's messed up here or there, don't let that throw you off, okay? So today, this is our first scheduled e-learning day. Just this a little bit. There we go. So this is our first scheduled e-learning day, and so we will actually not be in class today. You will be doing this from home. So there were two papers that you would have picked up for today. The Scientific Measurements Recording Review handout, page 14. Recording measurements on a manual device, page 15. Now, I would have handed those out to you in class yesterday, so you should already have those in hand. Yesterday, we completed Lab 1-1 on basic lab procedures, so that was due today. I'm collecting that for a grade, and so you will be turning that assignment in, sending it to me via Canvas. There are instructions for submitting assignments on Canvas on my homepage. All right, so make sure you refer to that. It will be there, and make sure you do that today. Now, if you have questions on how to do that, of course, you can always ask a classmate, or if you're stuck, you can always email me, of course. You may check your answers if you haven't already. So yesterday in class, if you did not have a chance to go through all that, I will have the answer key with sample data from me, of course. Normally it's posted on the board, and it is posted on the board, but I would also have that available to you on Canvas so that you can check it from home before you turn your assignment in to me. Okay, so today, here's our agenda today. Today during e-learning, you're going to take both the lab safety quiz and the lab equipment quiz in Canvas. So I hope you've been studying for those. Again, you guys have all taken quizzes in Canvas before, I assume, and so that shouldn't be too awfully difficult. They will be ready and waiting for you, okay? I'm then going to briefly go over the Scientific Measurements Recording Review handout, which is page 14. This is a review from last year on how to properly record and round a measurement. I can't stress enough, guys, how critical this is, all right? Our devices, our measuring devices, all have varying precision levels. And that precision level then determines how you record a measurement from that device. And that must be done correctly. If you don't do that correctly, then all the calculations that we do based on the measurements we take from those measuring devices are going to be screwed up. I mean, there's really no other way to say it. Especially when we get down to rounding final answers correctly with significant figures and precision levels and all that stuff, which we're going to go over very soon. But it all starts with this. It all starts with measuring and recording correctly. And so this is critical not only in chemistry, but also in all of the physical sciences, which involve lots of numerical data, okay? So I'm a real stickler on this, not only in this unit, but through the entire school year. So we're just going to have to get it down and make it part of our daily habits, okay? So we're going to go over that. There's a very short assignment, which is page 15, that goes with this review. That will be due tomorrow when you return to class. Also, as promised, I have assigned your first online homework in mastering. Unit 11A Matter. That is due this coming Monday by 7:30 a.m. All right. You would have already received in class the instructions for getting registered in mastering. It's done through Canvas, just like it was last year. And so you should have already done that, or if you haven't, you need to do that today so that you can get going on this assignment here. I'm a real stickler on mastering too, all right? It's due when it's due. I usually assign them anywhere from 2 to 3 to 4 to 5 days out. It's done on your own time. There's not class time to do mastering. All right, so what you'll be doing that then is working that into your normal routine. All right, there is no late policy on mastering. All right, the fact that you have multiple days to do it, I don't alter due dates. Okay, if it's due Monday morning at 7:30, that's when it's due. It shuts off at that time. If you work on it after that, it might let you do it, but it's not going to record a grade. All right, whatever grade you have, 0 up to full value at the time that the mastering assignment is due, that's what you get. Okay, so make sure you're aware of that. As a reminder with mastering, you can quit working in it anytime. It'll always go back to where you left off when you return to it. Everything you do is saved, and so you can always go back to it. You don't have to do it in one sitting. If you ever want help, skip those problems and ask me. I think mastering allows you 5 or 6 chances. I don't remember which. If you've done 2 or 3 chances on a question and you haven't got it right yet, unless you just want to throw it away, I think it would be best for you to check with either a classmate or with myself. You can always email me and ask me questions about mastering. I'm willing to help you with that. And so there's no point in not getting credit for a mastering question. There's just no point to it. All right. So like I said, if you get to 2 or 3 tries and you're not getting it yet, my advice is skip it, get a hold of me or somebody else, and I'll help you through it. Okay? Also, as a reminder in mastering, your e-text, your chemistry textbook is uploaded on your mastering homepage. You will have access to it there. Okay? So that takes care of that. I think that's all for today in regards to our schedule. So let's move along, I guess, to reviewing how to record and round a measurement. So let me get the screen flipped here. And there we go. So this is page 14. Mass and volume measurement, recording, and out. One thing, all measurements must be written as decimals. And of course, we will round appropriately based on the rules we're going to be discussing. No fractions, all right? Don't do fractions in chemistry. And also include the correct unit, of course. Okay? That goes without saying. So I want to first talk about, we have 2 basic types of devices. We have electronic devices, which basically do take the guesswork out of recording for us. And then we have manual devices where we have to make that determination how to record the measurement ourselves. So let's start with measuring mass, because we have an electronic device for that. Of course, the electronic balance. So I have one here, all right? And I don't know if you can see this or not, but our electronic balances go out 2 decimal places. So having said that, there is no guesswork then as to how you round a number taken from that device. If I just take this graduated cylinder here and place it on there, it says 147.98 grams, and that's what I'm going to record. I'm not going to record 147 or 148 or round it to 148.0 or take it out another decimal place or whatever. That says 2 decimal places. That's what you write down. Okay. Now, as I say that, this is flipping back and forth from 147.98 to 147.99. I mentioned this in the lab the other day. It's doing that because the actual mass of this graduated cylinder is somewhere in between those two numbers. It's an extra decimal place or two or however many, we don't know, beyond what this device is able to do. So what do? Well, you don't round it any further than the 2 decimal places, I can tell you that. You just pick one. If it seems to be laying on one number longer in time than it does the other, use that one. Otherwise, just guess. I don't care. But pick a number, and it must be to the correct number of decimal places, which in this case is 2. Okay. Some quick review on the electronic balance itself. Always check to make sure that the units are in grams. All right. Now our electronic balances can measure mass in several different units. They are set in grams now, but if you don't see a little G next to the end of the number, someone's messed with it, and I need to reset it. So make sure you check that. Always press the on or tare button before weighing something so that it reads 0.00 grams when you start. If you're weighing solid particles or a liquid, you're going to need a container of some type to do that. All right. You can place the container. I mentioned this the other day too in the lab. You can place the container on the balance first, press the on or tare button to set it to 0, then place the solid object or the liquid in the container, and it will then only weigh that particular substance. It will take the container's mass out of the mix. Right? That's a handy dandy little way of doing that. Otherwise, you would have to weigh the container first, then put the solid particles or the liquid in the container, weigh it again, and then subtract the 2 numbers to get your mass of just the substance. So that's the longer way of doing it. Either way works, but again, we have a shortcut available to us if you want to do that. And the last thing is never weigh a solid chemical directly on the metal plate. So we don't want to put solid particles on this metal plate here because they could react with it, all right? And we don't want to do that. So instead, place the solid chemical on a weighing paper or a little plastic boats or containers or whatever you want to call them, or a beaker or whatever. Immediately clean up any spills on the balance, whether they be solid chemicals or liquid, all right? All right, so that's a electronic device, all right? So it takes the guesswork out of how many decimal places to record to. We have another electronic device that we use fairly regularly, and that is, of course, a digital thermometer. And our digital thermometers go out 1 decimal place. So again, when you are taking temperature with one of these, you are always going to record it to 1 decimal place. And let me make one last point about that. So let's say the temperature, well, actually the temperature in here says 23.0 degrees Celsius, which is about right. It's around 70, 72 Fahrenheit. All right. So 23.0, that's what you record, right? Just because it's 0.0 doesn't mean, oh, okay, well, I can just write down 23. No, you can't. All right. That's not to the correct precision level. Precision level says it's 1 decimal. That's what you put. Okay? That's what you put. All right. Graduated cylinder, measuring volume. Okay, so set this aside here. So a graduated cylinder is one of many manual devices that we use to measure with. All right, it's a manual device, which means we have to determine the precision level ourselves and then record and round our measurement accordingly. All right. So because graduated cylinders have the most divisions or markings, they're called graduations. They allow for the most accurate and precise liquid volume measurement. This is why we do not use beakers or Erlenmeyer flasks or anything else like that to measure volume. I think I mentioned this in the lab. Now, if it's an approximate volume, then a beaker is okay. So in other words, if a procedure says measure out approximately 20 mLs of distilled water, if it says that, you can use a beaker, all right, because it really doesn't have to be precise. But if it doesn't say approximately, then, and you're doing volume, you need to be using one of these, okay? Usually a 10, 25, 50, or 100 ml graduated cylinder is used to measure volume. This one's 100. We use all of those, really. When you measure the volume of a liquid, always read the liquid level from the bottom of the meniscus. I think you should all remember this. All right, so remember, in a cylinder, you put a liquid in there, the surface of the liquid is not flat. All right, it's not flat, it's curved. And this is due because water molecules are attracted to the sides of the graduated cylinder. They latch onto there. And the ones in the center are being pulled down in the middle by the other water molecules and by gravity, of course, because they're farther away from the glass around the edge. So you get a meniscus. Remember, you always read the volume underneath the meniscus, right? Underneath, okay? So since this is a manual device, we're going to have to determine the precision level ourselves. So here's the rule. Hopefully you remember it. If not, here it is. The rule for manual devices is this. You record the measurement one place further out than the value of the smallest marking on the device. All right? One place further out than the value of the smallest marking on the device. So, for example, on this 100 ml graduated cylinder, these markings here are by 10, 20, 30, 40, 50, etc. But there are markings, actually 10 of them, in between each of those labeled markings, which means the value of each one of those markings is 1 ml, or to the ones place. All right? So one place further out than the ones place is the tenths place, or 1 decimal place. So any volume measurement taken from a device like this, all right, whose value, the smallest marking, is to the ones place, you will record one place further, or 1 decimal place. Okay? So, likewise, if the smallest marking is to the tenths place, you would round to the hundredths place, or 2 decimals. If the smallest marking is the tens place, all right, then you would round one place further out, which would be the ones place. Okay, so whatever the value is of the smallest marking, you go one beyond that. Okay? Now that also happens on your electronic devices. All right? Now but they do it for you. All right, so the electronic balance, again, for example, it rounds to 2 decimal places. All right, the actual mass that is on there is beyond 2 decimal places. All right, but its precision level is only to 2 decimal places. All right, so that's where it rounds. So that last digit is estimated, just as the last digit that you use here is also estimated. Doesn't mean it's not valid. It just means that because it's based on the precision level of the device, but it is an estimate. All right. So if the meniscus is on a line and the measurement requires a decimal point, which this one would, then the last digit would be a 0. All right. So in other words, if this was laying right on the bottom of the meniscus of the liquid was laying right on 50, all right, it'd be 50.0. If it was laying on 53, it'd be 53.0, okay? Because you got to have that decimal place. If it's in between a line, then you make a determination as to what you think it is. If you think it's halfway in between the line, then it's 0.5. If it's not quite halfway, you might use 0.3 or 0.2. That's up to you, all right? But whatever you guys decide, that's what you record, as long as it's to the correct number of decimal places, which in this case is 1. Okay? So let me advance the page here. So here we have a 50 ml graduated cylinder, which actually is done the same way this one is, whereby the smallest marking is to the 1 ml. So the smallest marking is 1 ml, or the ones place, which means that we're going to round to the tenths place, or the 0.1 ml, or 1 decimal place. All right? And as you can see, they rounded this value based on the location of the meniscus to 43.0. They felt it was right on the line. So 43.0 mLs, which takes it out that 1 decimal place, which is correct. Okay. Over here, we have a 10 ml graduated cylinder. And as I look at this here, the labeled markings have a value of 1, or the ones place. But again, there's 10 markings in between there. So the smallest marking has a value to the tenths place. All right? To the tenths place, to the 0.1 mLs, or 1 decimal place. So how would we round a measurement taken from this graduated cylinder? Well, 1 past the smallest marking value. So in this case, we would round to the 0.01 ml, or 2 decimal places, which, as you can see, is what they did right there. They felt it was, halfway between 9.7 and 9.8, and so they estimated it to be 9.75. Again, 2 decimal places. Okay? All right, let's go to the next, for the back side of this handout. Measuring solid volume. All right, we're going to get into a ruler here in a second. So how you measure a solid depends on whether it has a regular, which is measurable, shape, or an irregular shape, which is not measurable. If the solid has a regular shape, such as a square, rectangle, triangle, cylinder, etc., then its dimensions can be measured with a ruler, and we'll talk about the ruler here in a second. And then its volume could be calculated using some geometry equation. All right. If the solid has an irregular shape, that's pretty irregular, then its volume must be determined by water displacement. I know you guys have done this before. This shouldn't be a big surprise. Is it as accurate as measuring directly? No, but it's pretty dang close. All right. As in measuring liquids, you would use a graduated cylinder for that. So you would want to make sure that the graduated cylinder was large enough for this to fit in. All right. That would be important. You would measure a predetermined volume of water. Right. Make sure it's deep enough to completely submerge your solid. Carefully add the solid to the water. Don't just dump it in there, because if you do, you could splash water off the top, or heaven forbid, you could break the glass of the graduated cylinder if your object's really dense or really heavy. So, be careful when you do that. And then measure the volume again where the solid and the water are both in there. And then you subtract the 2 volumes, and you have the volume of the solid. Okay? So, regular versus irregular volume measuring of solids. Now, if we can measure regularly, length, width, and height, or whatever, then we're going to use a ruler. All right. So a metric ruler is used to measure length. Okay. So our rulers, of course, like most, have centimeters on one side, inches on the other. As you can see, I taped my inches side over. I did that years ago. We don't use English measurements in here, all right? We use metric, period. And so get used to that, all right? So, so this ruler here is basically the same as this. So we're going to look, it's a manual device, just like a graduated cylinder. So we have to determine what the value of the smallest marking is. So here, the the labeled markings are 1 centimeter, but again, there's 10 in between there. And so the smallest marking has a value of 0.1 centimeters. 0.1 centimeter, or 1 decimal place. Right? Which means then that we round one place beyond that. All right? So we're going to round to the 0.01 centimeters, or 2 decimal places. Okay? So as you see here, this apparently is the object they were measuring. It's somewhere between 2.3 and 2.4 centimeters. It's got to go out 2 decimal places. They felt it was about a third of the way between them, 2.33 centimeters. I want to caution you with rulers. I see this mistake more with rulers than any other device. All right? So you measure something with a ruler and it's right on 10 centimeters. All right? People will inevitably write down, oh, it's 10 centimeters. And that's not right. All right? Because this device needs to be taken out 2 decimal places, it's 10.00 centimeters, not 10. All right? You got to remember that. Like I said, if you record the measurements incorrectly, then when we do the math, that's what chemistry is, we do the math with those measurements to determine something we need to find out, the math's wrong. All right? The math's wrong. The answer's wrong, but it all starts with this right here. All right? It all starts with this. Accuracy and precision. And we're going to have a whole lesson on this, but I just want to briefly review this with you quickly. In science, we want to make accurate, precise measurements. Measurements that are accurate are close to the true value for that, whatever it is you're measuring. So for instance, if this desk is exactly 2.5 meters wide, all right, and I have the 6 lab groups come up and measure the width of this lab table here, and some gets 2.5, 2.4, 2.6, 2.5, 2.4. However close each of those individual measurements is to the true value of this width, that's a measure of accuracy. All right? Accuracy is how close you get to what you're supposed to get. Simply put. Okay? Every measurement has some degree of uncertainty. We've already talked about that. This uncertainty is the result of the last decimal place that we estimate. Like I said, the last digit that we record in a measurement is estimated. Right? Is it exact? No, it's not. So it's estimated. But again, that doesn't mean that it's not valid. That just means it's estimated. Okay. The more lines or divisions an instrument has, the more digits you know for sure. All right, so the more precise a device is, the more decimal places it goes out. Okay, you're going to get a more precise answer. Now, precision in regards to group measuring involves the mean. Okay, so again, if we're measuring the width of this table, and it's we said it was 2.5 meters, which would be then how accurate you are when you measure it, how close you are to that. But now let's say the 6 groups measure, and again, 2.5, 2.4, 2.6, 2.3, whatever. We add those, if there's 6 groups, we take those 6 measurements, add them up, divide by 6, and we have a mean, all right, or an average. How close your group gets to the mean, right? In other words, how close your group's measurement gets to the average of everyone's. That is a measure of precision. All right? And so, again, I'm going to have a whole lesson on this and calculations involved with accuracy and precision. But I wanted you to at least have a general idea of what we're referring to. So accuracy is a measurement of how close you get to what you're supposed to get. Precision is a measure of how close you get to the average of everyone who measured the same thing. Okay? All right. I think that's the handout. Let's take a quick look at the assignment. As I mentioned in the schedule, it's very short. So let me pull it up. And here it is. So here's what you are supposed to do. All right. Take a look at, there's only 5. All right. Take a look at each measuring device, and then it tells you here what you're measuring. So the first thing is for you to do is the first column here is determine the value of the smallest marking. Right? Is it the ones place, the tens place, the hundreds place, or does it go out some decimal places? Is it the tenths, the hundredths, the thousandths, whatever? That goes here. Based on the value of that smallest marking, how do you round it? Remember, it's one place further. So if the smallest marking value is the ones place, you're going to round to the tenths. If the smallest markings value is the tens place, you're going to round to the ones. If your smallest marking is the hundredths place or 2 decimals, you're going to round to the thousandths place or 3 decimals. Right? 1 past the value of the smallest marking. And then based on how you are to round, this last column is measuring. Right? Look at the measurement and record it properly. Right? Like I said, there's only 5 problems. Shouldn't take you but a few minutes. But again, I cannot stress how important proper measuring is. In chemistry, it's absolutely crucial. Right? So I think that is it for today. Again, remember all the stuff you need to do for during your e-learning day today. Get those quizzes in Canvas done on the lab equipment and the lab safety. Make sure you are registered and up and running and mastering. All right, and be working on that first assignment that is up and loaded for you to go. And then, of course, this short assignment here. So until tomorrow, this is Mr. Keister signing off. Stay safe, everyone, and I will see you soon. All right, so long, everybody.